Good afternoon, students.
Good afternoon, ma'am.
Okay, very good afternoon. So in our last class, we discussed about the Joules law of heating effect of electric current, and we derive an equation for heating effect of electric current, and that equation is known as Joules law of heating effect. Okay, is it clear?
Yes, ma'am.
Okay, so first of all, we can define all the terms. After that, we can move to the practical applications of heating effect of electric current. So starting with Elsa, what do you mean by heating effect of electric current?
Ma'am, it's a conversion of heat energy into.
Is it conversion of heat energy?
So, ma'am, conversion of electric energy into heat energy.
Very good. The conversion of electrical energy into heat energy is known as heating effect of electric current. Dominic, we have one more definition is there for the heating effect of electric current. What's that? Dominic? Another definition for heating effect of electric current? Same question to Shania.
The source of electric energy continuously gets dissipated in the form of heat.
Okay. So the source of electrical energy is continuously dissipated in the form of heat. Then we can call such effect as heating effect of electric current. Okay. Then Kshetra. State the Joule's law of heating effect. Here Fizan is ready to say the answer. So we can give yes, Kshetra. What is the state the Joule's law of heating effect?
Joule's law can be stated as a quantity of heat generated in a resistor is directly proportional to the square of the current, the resistance of the conductor, the time for which the current flows.
Okay, it is directly proportional to square of the current. Heat energy developed in a resistor is also directly proportional to resistance of the resistor and also directly proportional to the time taken to flow the electric current. Then Fizan, what is the mathematical equation for Joule's law of heating effect?
Square RT. J. I is equal to I square RT.
I is equal to I square RT. That equation is right.
I square RT.
I square RT is equal to LHS of the equation. Then only it becomes an equation. It must contain an LHS and RHS. RHS is right. I square RT. What about the LHS?
V is equal to.
Is it B? No. Srihari, the mathematical equation for calculating?
J is equal to.
H is equal to I square.
Yes, it is H is equal to. Here we are calculating heating effect of electric current Fizan. Heating effect. Heating effect is represented by H, capital letter H. So H is equal to I square RT. H is directly proportional to square of the current. It is also directly proportional to resistance of the resistor, and it is also directly proportional to the time taken to flow the current through that resistor. I hope all these topics are clear to you, right? Okay. So today we are going to discuss the practical applications of heating effect of electric current. So all of you write the next heading, practical applications of heating effect of electric current. Sean, can you give some examples for the applications of heating effect of electric current? Any examples? No problem. Whatever be the yes, Fisan. Electric toaster. Electric toaster is one example for heating effect of electric current. Similarly, any two other electrical devices?
Electric fuse.
Electric fuse. Very good. Electric fuse, electric toasters. Shania, yes. Electric kettle. Very good. Then
Iron box.
iron box. Very good. Iron box.
Electric oven.
Electric oven. Electric heater. Yes, hair dryer. Yeah. Then electric bulb also working based on this Joules law of heating effect of electric current. So there are lot of applications are there, lot of practical applications are there regarding with this heating effect of electric current. But in this chapter, we discuss only two applications in detail, that is about the electric bulb and electric fuse. So let us see how this electric bulb and electric fuse works based on the Joules law of heating effect of electric current. For Joules law of heating effect of electric current. The next topic, practical applications of heating effect of electric current. There are a lot of applications are there. Electric toaster, electric oven, electric kettle, hair dryer, all are working based on this heating effect of electric current. But in this chapter, we are mainly focuses on 2 points or 2 applications. One is electric bulb and other is electric fuse. So let us see one by one. So first of all, we are going to discuss about electric bulb. How this electric bulb is working based on the Joules law of heating effect of electric current. Have you ever observed this type of electric bulb?
Yes, ma'am.
Yes. And can you name the bulb? Is it CFL or LED?
Filament bulb.
It's filament bulb. The filament bulb. These bulbs are filament bulb. Or normally we are called it by another name. Or it is also known as incandescent bulb. Incandescent bulb.
There will be with 10 watt, 11 watt.
Yeah. This type of bulbs are mainly with 40 watt also. In our earlier days, in our homes, we are used with this bulb, incandescent bulb. And what about the color of the light produced by this type of bulbs?
White color.
Yellow.
No, it is not white color. It is in yellow color. It produces an yellow color. Okay.
Clear, that is yellow.
Yeah, sometimes it may be produce some kind of shadows and all. Normally, these bulbs nowadays also we are using this incandescent bulbs to give heat to the chicks. Okay, because one of the application of this incandescent bulb, it produces or it is dissipate a large amount of heat. That is one of the disadvantages of this incandescent bulb or the filament bulb. So first of all, we can describe the structure of this incandescent bulb. After that, we can explain how it is works on the principle of Joules law of heating effect. Okay. So here we have the filament bulb, or it is also known as incandescent bulb. This incandescent bulb consists of a outer glass covering. It consists of an outer glass covering, or it is a glass case. Okay, so the filament bulb consists of an outer glass covering or outer glass case. Inside this bulb, we have a filament. This part is known as the filament. Inside the bulb, here we have a filament. This filament is made with a strong metal called tungsten. The filament is made up of a strong metal called tungsten. Okay, so the incandescent bulb or the filament bulb consists of an outer glass covering. Inside this inside this glass covering or glass case, you can see a filament. This filament is made with a strong metal called tungsten. Okay. And students, do you know what is the function of this filament inside this bulb? Why we are using filament inside this incandescent bulb? What is its use?
Gets heated and produced.
Yes, very good. The function of filament is that whenever, if and only if this filament is heat as much as possible, then only it will produce a brighter light. So that is what is the speciality of an incandescent bulb or filament bulb. Okay. So if and only if this filament becomes too hot, then only it produces a large amount of light. So initially the light produced by this incandescent bulb will be very less. But if the amount of electrical energy consumed by the bulb increases, more and more energy consumed by this filament. As a result, the filament becomes more and more hot. After some times, what happens? It produces a large amount of light. So this is how the incandescent bulb works. So it is mainly consists of a glass case. Inside the glass case, you can see a filament. This filament is made with a strong metal because a large amount of the heat is passing through this filament. So there is a chance of breaking of the filament. So in order to avoid that, here we are making the filament with a strong metal. That strong metal is known as
Their voice is
tungsten.
breaking.
Okay, I think here the network is poor. That's why. Okay, so in order to avoid that breaking of the filament, here we are making this filament with a strong metal called tungsten. Here we are making this filament with a strong metal called tungsten. And what is the use of this filament or filament inside this incandescent bulb? If and only if this filament becomes too hot, then only the bulb produces a more brighter light. So that is why we are using this filament inside this incandescent bulb. And another question you can expect from this part is why we are using the tungsten as a filament instead of using copper. There are lots of metals are there. Copper is also a conductor. Aluminium is also a conductor. Silver is also a conductor. But instead of this copper, aluminium and silver, here we are taken or adopted the tungsten as a filament. What is the reason behind it?
Because
High melting point.
Yes, because tungsten is a strong metal with high melting point and high electrical resistivity. Okay, so here we are using tungsten as a filament because it possesses high melting point. This tungsten is possess high melting point and high electrical resistivity. High melting point and high electrical resistivity. So here the incandescent bulb, which consists of a glass case. Inside this glass case, you can see a filament. Filament is made up of a strong metal called a tungsten. The function of filament is that whenever this filament becomes too hot, then only it produces a large amount of light, or it emits a large or brighter light to outside. It dissipates a brighter light. And instead of using copper, aluminium and silver, here we prefer the tungsten as a metal to construct this filament because tungsten possesses high melting point and it possesses high electrical resistivity. So whenever a large amount of current or heat passing through this filament, it doesn't affect the filament, it doesn't break because the tungsten is with a high melting point. It can withstand even 3380 degrees Celsius temperature. No problem. If the 3000 degrees Celsius temperature is passing through this tungsten filament, no problem occurs to our filament. Yes?
that when we touch that bulb and when we break and it will blast, and sometimes
whenever the filament becomes broken, sometimes in the case of overloading or short circuiting, so some kind of current is passing through. So, suppose you just imagine if this incandescent bulb is capable of holding 40 watt current, but instead of this 40 watt current, in case of overloading or short circuiting, what happens? Suppose a 60 watt current passes through this electric bulb. What happens? The filament broken. The filament breaks. That is what is actually happens because of the damage of this incandescent bulb. Otherwise, no problem. It can even withstand 3380 degrees Celsius of temperature. Because the melting point of tungsten is 3380 degrees Celsius. So if the 3000 degrees Celsius is passing through this filament with the made up of tungsten, no problem will be happen to this incandescent bulb. It can withstand. Okay, so now we can see, so this kind of light is produced by our incandescent bulb or the filament bulb. It produces an yellow light. So whenever the temperature or whenever the filament becomes heated, it becomes white in color and it emits a yellow light. It emits an yellow light to outside. So now let us see how this electric bulb is work based on this Joule's law of heating effect of electric current. When electric current is passes through very thin, high resistance tungsten filament of an electric bulb, the filament becomes white hot. It becomes white hot in color and it emits an yellow light. It emits yellow light. When electric current is passes through very thin, the filament is very thin. It's a very thin material. Okay, and this filament is made up of a very strong metal called tungsten. It is very thin in nature. So whenever the electric current is passing through this tungsten filament of the electric bulb, the filament becomes white hot and it emits yellow light.
And the filament become white
hot. The filament becomes white hot. White hot. It becomes white in color. The filament becomes white in color and it emits yellow light. That is much brighter light emitted by this filament. So when this bulb, electric bulb emits a very bright light, what is the condition for that? Geraldine? Whenever the electric bulb emits much bright light.
Dark. We switch off the.
No, here Geraldine is ready to say the answer. Yes, Geraldine. When our electric bulb emits more light to outside.
When more electric current pass.
Yes, when more electric current passes through the tungsten, or when the tungsten becomes much hot, then only our electric bulb emits more brighter light. Okay. Can I move to the next slide? Okay.
One minute.
So this is how the electric bulb is working based on the Joule's law of heating effect. So this is one of the disadvantages of this incandescent bulb or the filament. We know that what do you mean by heating effect of electric current? What do you mean by heating effect of electric current? The source of electrical energy is continuously dissipated in the form of heat. So here we are applying the electrical energy to where? To electric bulb. The major portion of the electrical energy is used to heat the filament. Instead of producing light, the major portion of the energy is used to heat the filament. So it consumes, this type of incandescent bulb or filament bulb consumes more amount of the electrical energy as compared to that of the other bulb. That is why the KSEB not promoted the use of incandescent bulb. Actually, they are banned the use of this incandescent bulb. Nowadays, does we use this type of filament bulb in our home? Do we use this? No. Instead of incandescent bulbs, we are preferred to which type of bulbs?
Tube like.
Tube light or CFL bulb. Nowadays, instead of CFL, we are promoted to use LED bulbs. LED with white light. So this LED bulbs doesn't contains any kind of this filament and all. Because if the bulb contains filament, what is the disadvantage? The most of the electrical energy is converted in the form of heat. In order to heat the filament, then only it produces a bright light. Okay.
Small light that in toys and all, one small light will be there. Inside that one small thing we can see.
LED.
In the LED and small one.
Inside the LED, there will be no type of filament is present. No filament is there. Some particular type of gases are filled inside this other type of case of CFL and LED. Some particular type of gases are there, and that gases are responsible for, as a result of the collision of the electrons, that gases are responsible for the production of the light and its color. Here we will not discuss about that points and all. We are only discuss about the working of electric bulb, how it is working based on the principle of Joule's law of heating effect of electric current and all. Again, inside this glass case, here you can see some vacant spaces are there, some vacuum spaces are there. These vacuum spaces inside the glass bulb, or the empty spaces inside the filament bulb is filled with the gases like nitrogen or argon. The nitrogen and argon are filled inside the glass case of this filament bulb, inside the empty spaces of this filament bulb, in order to enhance its life of the bulb, in order to enhance the life. The nitrogen and argon gas are filled inside the empty spaces of the glass case of this filament bulb in order to enhance the life of the bulb.
Are filled in the
nitrogen and argon gases are filled in this empty spaces of the glass case of incandescent bulb. Nitrogen and argon gases are filled inside this empty spaces of the glass case of the bulb. Here you can see nitrogen and argon gases. Why we are filled this empty spaces with nitrogen and argon gases?
the filament can take place
To enhance the life of the bulb. So then the bulb will work for a long time. It increases the lifetime of the bulb. So that's why we are filled this empty spaces of this glass case with the nitrogen and argon gas. It enhances the lifetime of the bulb.
when we throw that bulb in the wall, or which would be very big sound.
Then it will be broken.
Very big sound.
Yes. Otherwise, it will be remain for a long time, because here we are filled it with the nitrogen and argon gas. Okay, so that's all about the working of electric bulb based on the Joule's law of heating effect. So according to Joule's law of heating effect, we know that the current that is directly proportional to the square of the current, resistance offered by the resistor, and the time taken to flow the current. Or heating effect of electric current means the electrical energy is completely or continuously dissipated in the form of heat. Here we are applying the electrical energy to this bulb, and this electrical energy converted into the heat in order to heat this filament. The filament becomes hot and it produces or emits a large amount of the light. So here the electrical energy get converted into heat energy. To heat the filament, thereby it produces the light energy. Is it clear? Karthik, why we are prefer the tungsten as a filament inside this incandescent bulb? What is the reason behind it?
And because it's more, it has high melting point.
It has high melting point. One more point is there. High melting point, and also
Boiling.
not boiling point. Here we don't need boiling point, because we are not needed to boil the bulb. Gauri?
High
electrical resistivity. There are 2 points are there, because the tungsten possesses high melting point. Tungsten possesses high melting point. That is, it takes a large time to melt this filament. It possesses high melting point. The second one, it possesses high electrical resistivity. So this is a sure question always that is asking from this session. Why the tungsten is used as a filament inside the filament bulb or incandescent bulb, because you need to write only these 2 points, because tungsten possesses high melting point and it is also possesses high electrical resistivity. Tungsten possesses high melting point and it is also possesses high electrical resistivity. That is why the tungsten is used as a filament inside the incandescent bulb. Is it clear? Okay. Now we have the second application of Joule's law of heating effect of electric current, that is electric fuse. The second application of heating effect of electric current, that is electric fuse. Here you have the image of electric fuse. Have you ever seen this electric fuse?
Yes, ma'am. In here it is.
Yes.
In my home it is there.
In olden days, in our electric circuit boards consist of this kind of electric fuse. And what is the use of electric fuse actually?
We can replace
It
when
melts when high voltage goes through.
Is what melt? Is this entire electric fuse is melt?
No, ma'am, there is a wire.
Yes. Here you can see a wire. In this image, you can see a wire, and that wire is known as fuse wire. Fuse wire. Actually, this fuse wire is one of the major part of the electric fuse. Okay. Actually, electric fuse consists of these parts. It consists of a base. It consists of a metallic base. This is metallic in nature. It consists of a metallic base. And 2 contacts are there. 2 contacts. By connecting these 2 contacts, we have a wire. That wire is known as fuse wire.
And this thing
Fuse
now.
wire is, yes,
And this thing and this.
yes, Rizan.
And this is the fuse now that.
Ah, yeah. This entire arrangement is known as the electric fuse. And one of the major part of the electric fuse is known as fuse wire. Fuse wire.
Yes,
And do you know how this fuse wire is made up of? Which metal is used? Okay, copper. Only with copper?
Copper and iron.
Copper is used, right? Aluminium. Aluminium is used. Copper, aluminium.
When we will replace the and it will when we will put then current will come. How that and the copper.
Sometimes when a high amount of a large amount of current passes through this electric fuse, what happens? This fuse wire becomes broken. Okay, thereby the circuit becomes unopened, so no current will be flow through the circuit. So in such cases, we need to replace this fuse wire. So the fuse wire is made up of mainly with copper, aluminium, tin, and lead. Tin and lead. Not tin. Instead of tin, you can write iron. Iron and lead. But normally in our homes, we are prefer this copper and aluminium wires to connect this fuse wire. To use as we are mainly use the copper and aluminium metal as the fuse wires because they are easily available. Because the iron consists of or iron possesses a large resistance as compared to that of the copper and aluminium. That is why we are most preferably choose this copper and aluminium as our fuse wires. Copper and aluminium metals are preferred as fuse wires. Okay. Now, what is the use of this electric fuse? Actually, electrical fuse, it makes a large function. It possesses a good function. Electric fuse is a device that to protect our electrical appliances whenever an excess amount of current is passing through the circuit. Okay, so all of you write the next statement. Define electric fuse. Write a definition for electric fuse. After that, we can explain how the electric fuse is working based on the principle of Joules' law of heating effect of electric current.
This full unit, right?
Okay, here you have the definition for electric fuse. Electric fuse is a device that is used for protecting household wiring and electrical appliances. Only need to start from here. The electric fuse is a device. Electric fuse is a device for protecting household wiring and electrical appliances. Electric fuse is a device that is used for protecting household wiring and electrical appliances. It is used for protecting household wiring and electrical appliances. When we are using this electric fuse, what is the main function when this electric fuse is function?
And for when the
When a large amount or when a excess amount of current is flowing through the circuit. When an excess amount of
current is flowing.
yes, when an excess amount of current is flowing through the circuit.
Going to circular.
Flowing through the circuit, electric circuit.
Okay.
Okay, so electric fuse is a device that is used for protecting household wiring and electrical appliances when excess amount of current flowing through the circuit. Okay, so this is what is the definition for electric fuse. Electric fuse is a device that is mainly used for protecting our household wiring and electrical appliances from its damage when an excess amount of the current is flowing through the circuit. Okay. You don't need to copy down the second point.
And when prevents fire in the house, that can be right.
Ah, yes.
Oh.
And the third point, you can write the third point. A thin fuse wire. A thin fuse wire. A lower resistance. With a lower resistance. And melting point. Lower resistance and lower melting point. A thin fuse wire with a lower resistance and lower melting point. A thin fuse wire with a lower resistance and lower melting point is the major part of the fuse, electric fuse. It's the major part of the electric fuse. Okay, a thin fuse wire with a lower resistance and lower melting point. So here in the case of fuse wire, the melting point should be less. Then only it is easily broken whenever excess amount of current is passing through the circuit. So if and only if the fuse wire is broken, then only it becomes a open circuit. Thereby it protects the electrical appliances from its damage. Okay. So the thin fuse wire with a lower resistance and lower melting point is the major part of the electric fuse. Now you can write the last point. This is what is actually explaining the working of electric fuse. When the current in a household electric circuit rises too much due to some reason means it can be either overloading or due to the short circuiting process, then what happened to fuse wire? The fuse wire gets heated too much, it melts and breaks the circuit. This prevents the fire in house. This prevents the fire in house. I hope all the points are clear. The first point is, yes?
My phone's charge is finished. My phone's charge finishes. That's why I was gone.
Okay.
It power off that.
Okay, Fizan.
Ma'am, that last time when excess amount current is flowing through the circuit, after that, which
one?
that ma'am and access that point that about that electric fuse you right now. Then after that you want to iterate it.
I will repeat all the points once again. What do you mean by electric fuse? Electric fuse is a device that is used for protecting the household wiring and electrical appliances when an excess amount of current is passing through the circuit. When an excess amount of current flowing through the circuit. Then the second point, the thin fuse wire with a lower resistance and a lower melting point is the major part of the electric fuse. The major part of the electric fuse is a fuse wire with a lower resistance and lower melting point. Then you can write the fourth point here. So when a current in a household electric circuit rises too much due to some reason, the reason can be either overloading or it may be due to short circuiting. The fuse wire gets heated too much, it melts and breaks the circuit. Breaks the circuit means then there will be no current is flowing through or large amount of current is flowing through our further electrical appliances, because here the fuse wire breaks the circuit. This prevents the fire in house. This is the last point. Is it clear?
Yes ma'am, 1 minute write it.
So try to study all these points one by one. First of all, you study the definition for electric fuse. What do you mean by electric fuse? It is a device that is used to protect our electrical appliances and household wiring when excess amount of the current is passing through the circuit. Then second one, what is the major part of the electric fuse? What is the major part of electric fuse? Shania? Not Sania. Sorry. Sania. Question is to Sania. Major part of electric fuse. Sania.
Yes, ma'am.
What is the major part of electric fuse? Same question to Angelo.
Electrical wire.
If it is an electrical wire, there is a particular specific name is there. What's that? Major part of the electric fuse. Raya? Yes, it is the fuse wire. And what is the speciality or characteristic of fuse wire? Raya? What is the characteristics of this fuse wire? Yes, it is thin in nature. Okay, then
It has high melting point.
Is it has high melting point, then surely it will damage your electrical appliances.
Low melting point.
No, it possesses low melting point. It possesses low melting point. Then what about the other characteristics? It possesses low melting point and
Lower resistance.
lower resistance. So this is the characteristics of fuse wire. So the major part of the electric fuse is fuse wire. Characteristics of fuse wire is it possesses low melting point and low resistance. And then how it is prevents or how it is protect our electrical appliances. Whenever an excess amount of the current is passing through the electrical appliances, our fuse wire becomes too hot, it breaks, thereby stops the flow of current through the electric circuit. As a result, it prevents the fire in house. Otherwise, sometimes you may be heard in some cases, some incidents are occurs in some shopping malls and all. They will catches the shopping malls catches the fire, and the reason behind it is due to the short circuiting and all. So whenever the overloading or short circuiting is occurs, if this electric fuse doesn't function properly, then it may catch fire.
1 minute. Then the fuse wire gets heated too much.
Then the fuse wire gets heat too much, melts and breaks the circuit. That's all. That's all. Is it over?
1 minute. Right.
Okay.